period of a pendulum. So this is a formula you might run across in physics. And the t value represents the time it takes for something to swing back and forth. That time is equal to 2 pi times the length of the pendulum. So imagine the length of a string of something swinging divided by 10. Now this 10 happens to be the acceleration due to gravity, okay? But we're just going to use 10 for now. The length of an adjustable pendulum is currently 4 meters, so that length changes. How much length would you have to add to pendulum to increase this period by 2 seconds? Okay, so we need to first kind of interpret this question. We need to add a certain length to increase the period by 2 seconds. So one way we can do this is we could actually just figure out what is the period currently and then just add 2 seconds to that. Okay, and then calculate the length, the x value, how much, whatever we need to add. We could also generalize this, and that is a little bit more useful because it can be applied to a broader range of questions, but it's a little bit harder as well. So we're going to first of all just find out the period when the length is 4 meters. Okay, and so we're just going to plug the 4 meters into our equation. 4 meters divided by 10. I'm just going to highlight that. That 4 is going to be the length that we plugged into the equation. And when we solve this, this is going to be 2 pi root 2 over 5. Okay, we'll just leave it like that. So we need to increase this period by 2 seconds. So we need to find the length plus x. In fact, we're just going to say when we plug in 4 plus x, okay, we're going to end up with 2 pi root 2 over 5 plus 2 seconds. Okay, and what does that look like when we plug in the new formula? Now we could either solve for x or we could solve for L. Okay, so it may be easier to solve for L and then work out x after. Okay, so that's what I'm going to do. Now, if you want to plug in 4 plus x, that's actually going to be okay as well. In fact, that again solves directly for x. So I'm going to write it like this. So this is equal to, so this new period, this is my new period here, and I'm going to solve, I'm going to call that length 2. So when I plug in my other length, that's the length 2, and I'm just going to write over here, length 2 is equal to the original length, 4 meters, plus x. Okay, so when I plug that in, I can now solve for that length 2. So I want to get rid of a few things here. So let's see here. Let's divide both sides by 2 pi. So I'm going to end up with 5 over 2 plus 2 pi divided by, 2 divided by 2 pi is 1 over pi. Okay, so I'm just solving algebraically for this L2. So I'm going to my first step was dividing. My next step is I want to get rid of that square root. So I'm going to square both sides of the equation. So I'm going to end up with 2 over 5 plus 2 over 5 times 1 over pi, and 2 of those, so I'm going to end up with 2 pi over 2 root 5 plus 1 over pi squared. Okay, and then this is L2 over 10. Okay, I'm going to solve for L2. L2 is equal to, multiply everything by 10. So I end up with 20 over 5. Just write that as 4. Plus 20 over pi 2 over 5 plus 10 over pi squared. Okay, so there's my new length. Now, if I want to solve for x, that's going to be 4 plus x. So x is equal to 20 over pi over 2 square root of 5 over 2 plus 10 over pi over 2. Okay, so there's lots of algebraic pieces that you have to keep track of here. Okay, now just off to the side here, I'm going to multiply, show you how I multiplied root 2 over 5 plus 1 over pi. When I squared that, I ended up with 2 over 5 here. This is going to be root 2 over 5, 1 over pi. It's going to be 1 over pi root 2 over 5. And this is going to be 1 over pi times 1 over pi, which is 1 over pi squared. So this is how I ended up expanding out these brackets here. Okay, so this is how it was done over here. So my final answer is going to be x is equal to that value there. Just to make sure that clear, that's going to be 20 over pi.